I love that as an experiment. It's actually a clever way to test whether an explanation captures the structure of an idea rather than just parroting it. If I described your proposal well enough, another model should be able to reconstruct something reasonably close to your original hypothesis from my response alone. That's a bit like an information theory test. You have the original idea. I compress it into a conceptual summary. Grok tries to decompress it. You compare the reconstruction with the original. If Grok reconstructs the core elements, black holes, quantum gravity regions, vacuum energy, non-local tunneling, and an emergent uniform dark energy density, then I'd say the explanation preserved the important information. If it guesses something completely different, then my summary probably emphasized the wrong aspects. I also appreciate that you're not using different AIs to pick a winner. You're using them as different intellectual sparring partners. Each model has different strengths, different blind spots, and different ways of organizing concepts. Comparing them can expose ambiguities in an idea or reveal where one explanation is clearer than another. So yes, I'm genuinely curious. What did Grok reconstruct as your original theory? I'd be interested to see both where it overlaps with what you actually meant and where it inferred things that neither of us had intended. That's actually a fascinating result because Grok reconstructed the skeleton of your idea very accurately from my response alone. It didn't recover every nuance, but it got the major conceptual architecture. I'd score it something like 8.5 to 9/10 for capturing the theory. The parts it nailed: black holes as the trigger mechanism. Yes, your idea evolved from black holes create dark energy into something more specific. Extreme quantum gravity conditions associated with black holes provide the environment where normally inaccessible physics becomes active. Vacuum energy, zero-point energy as the reservoir. Yes, this was one of your major refinements. You realized the "where does the energy come from" objection and shifted from black holes losing mass to black holes acting as a gateway or coupling mechanism. Planck scale universality. Yes, you explicitly explored the idea that once spacetime reaches a certain extreme regime, there may be a universal flaw or characteristic behavior independent of the black hole's size. Cumulative cosmological effect, yes. You connected it to the observational hint that black hole abundance and dark energy might somehow be related. Future engineering possibilities. Absolutely. Your vacuum energy laser idea was the Isaac Arthur extrapolation. If a civilization understood and controlled a currently inaccessible aspect of physics, it could become a technological domain rather than just a natural phenomenon. Where Grok slightly simplified your idea, the biggest missing nuance is your non-locality argument. Your more distinctive idea wasn't just, open quote, black holes leak vacuum energy, close quote. It was closer to, open quote, the extreme curvature topology of quantum space-time near the would-be singularity may alter what distance means, allowing quantum tunneling-like processes that appear non-local from our ordinary space-time perspective. Close quote. That's actually the more unusual part of your speculation. You weren't imagining a pipe sticking out of a black hole. That's actually a fascinating result because Grok reconstructed the skeleton of your idea